Okay, so I want to jump right into implementing a function named include. And the idea is we are given a list of string values, and we want to know, does a list include a specific value in it? So how might we write a function that, given a list of any length and some value we're searching for, we can check to see if the list contains that particular value? So if you imagine from some pseudocode first, we can imagine an algorithm that looks something like this. Given any list and a value v, if the list is empty, of course the list does not include the value v, so we would return false, right? We're trying to search to see, does value v exist in this list? And if we have an empty list, of course it doesn't, right? Otherwise, though, what we're going to do is check if the first value of the list is equal to v. And if so, we'll return true, right? If that's not true, what we're going to do is, rather than loop or do anything clever or fancy here, we're just going to apply this same process recursively to the rest of the list. So we're going to run the same algorithm again, but on the rest of the list. And we start back at step 1 for the rest of the list, right? So what I'd like you to do right now is try pausing the video and going to today's lecture material. And in today's material, you will see a file named OOincludes app. And what this file is doing is importing our functions for list processing from the intro.cs list library. We're setting up a list of names: Kevin Guskowitz, Kevin Bacon, and Roy. And what we're trying to do is see if the string Kevin Bacon is included in that list of names, right? So if Kevin Bacon is in this list of names, then we should return true. But you'll notice that our implementation of this function currently does not return true, right? It simply hard codes a return value of false. So this function has a parameter that is an input list and an input search string, and your goal is to implement this includes function such that if you search using the includes function for a value that exists, it should return true if that value is there and false otherwise. So I'm going to put the pseudocode back up on the screen for a moment and give you a chance to try working on this. All right, so let's try working through this example together. And we're going to code this up step by step, okay? So I'm going to go ahead and delete the skeleton implementation that we had there to begin with. And let's see, so the rule said if it's empty, so if the list is equal to the empty list, which is null, right? If list is null, then we will return false, right? So what's the intuition here? We've reached the end and did not find the search string, right? So when we reach the end of the list, if we don't find the search string, we'll return false because the list, of course, does not include what we were searching for. Else, if the first node of the list is equal to the search string, right? So if we're checking at the very start of our list and that node is equal to what we're searching for, then we'll return true. Right? So this is the value we're looking for. Okay. And lastly, what do we do if we reach a point where the list isn't empty? So that means there are potentially more elements beyond the element we're currently checking. And also the element we just checked, the first node of our current list, isn't equal to what we're searching for. So what might we do? Well, we can return the includes function applied to the rest of the list. And what are we searching for? Well, we're still searching for the same thing, right? So else we are searching or testing whether the rest of the list includes search string, right? So what's the intuition here? Again, we're saying, okay, we're trying to define what happens at any given step of this algorithm. And so our first step is we see if we've reached the end. And if so, we know that we haven't found what we're looking for. Otherwise, if we test the first element of this list and see that it is equal to our search string, then we'll return true. And lastly, if neither of those cases hold, we're going to apply the same algorithm, meaning we're going to make those two steps, those two checks, for the rest of the list until we reach one of those two base cases, right? So in this example, there are two base cases that we can reach in our code. Either we reach the end of our list and we reach the base case where we didn't find what we were looking for, or we reach the case where we do find what we're looking for, in which case this will return true. Right? And we'll think through in just a moment how is it that returning includes the rest of the list is ultimately going to give us a true or false value out of this. But let's go ahead and test this out and see if we've got a working example. So I saved it. And I now am getting true for Kevin Bacon is in the names list. We could try another one. We could try Roy Williams. And if I save this, we see that it's false because I only have the string Roy without Roy's last name in the list of names. So if we were to try just Roy, we would see that true is what's printed when we includes that particular, whether names includes that particular search string. Right, but I'm going to change this back to Kevin Bacon so that the output makes a little bit more sense here and so that your example in code aligns with what we were talking about in the slides. All right. So this is a recursive function for testing whether a list contains some search element. Right? So this is us traversing that list. And when I use the word traverse, I mean moving through a list one by one in some particular order. So what are we seeing here? Well, notice we're always checking if the list is empty. This is one of our rules for using recursion and processing a list. And we are making our recursive call on the rest of the list. So notice this is the recursive call to includes, and we're making that on the rest of the list. So let's imagine this execution in a visual sense. So if we imagine we're testing whether or not the list of Ramses, Roy, and Kevin includes the string Kevin, which of course it does based on us just reading this slide, let's think through how this would be evaluated using a substitution model. And by that I mean we're going to say that this includes function call could be substituted with the includes function call of Roy followed by Kevin followed by null. It's for the search string Kevin. And why am I saying that this could be substituted with what we're seeing down here below? Well, if we looked at includes and the list was Ramses, Roy, Kevin with a search string Kevin, we can imagine that the list is not null, right? So we don't go into this case. Else, if the first of the list is equal to search. So the first of the list is Ramses. That is not equal to Kevin, what we were searching for, so we wouldn't go there either. So now what we're saying is what we're going to return, this is ultimately going to be substituted with a call to includes on the rest of the list and with the search string. And so here we're seeing those substitutions being made. We're seeing this call to return is calling includes, or this return statement is calling includes on the rest of the list with that search string. Similarly, in this example, when we evaluate it, Roy was the first node of our list and search string was still Kevin. So the list was not empty, right? And the first element of this list was not equal to what we were searching for. So then we would substitute that call with a return to includes the rest of the list using the search string Kevin, right? And so that call would evaluate to true, right? So if we think about that, includes where the list is Kevin followed by the empty string and the search string is Kevin. The list is not empty, so we don't go into this then block. But if we test if the first element of this list with Kevin as the first node in it is equal to the search string Kevin, that would return true, right? So we would substitute true here. And now we've reached the end of this recursion. So that true value is going to return back up to the function call where it was made. And it's going to be propagated all the way back up to the first caller of the includes function.